So in this segment, we look at the 2025, GCE paper 1 question in physics. So the question was saying that a wave on a string moves through a distance of 20 meters in 0.1 seconds. Then the question there was saying define longitudinal wave. Now, of course, when we talk about a longitudinal wave, it's a wave in which the vibration of the particle is actually parallel to the motion of the wave. So we can say is a wave in which the vibration of the particles is parallel. That's the key word, is parallel to the motion of wave. So what I mean is that if you have, let's take for example, you have this as a particle and the wave is going in that direction, it simply means that this particle will be oscillating to and fro. So it will be going back and forth if this is representing the motion of the wave. So the vibration is always parallel. So that's what you need to remember when it comes to a longitudinal wave. And a very good example of a longitudinal wave, sometimes they can ask you in the exam, is actually sound wave. Yeah, sound wave. Also, waves on a spring. Those are good examples of what we simply call as being longitudinal waves. If you notice the B part there, it says calculate the velocity of the wave. Now from the question there, the data that we have actually been given is that the distance that it was traveled through the string was simply 20 meters, and the time that it took is simply 0.1 second. Then the question says calculate the velocity. So remember, the velocity can also be interchangeably be said as the what? As the speed in this case. So you apply the formula speed is equal to distance divided by time. So speed is equal to the distance is a 20 meter. You divide by the time, which is 0.1 second. So if you grab your calculator and try to calculate that would be 20 divided by 0.1, that is going to give us a 200. So therefore that is a 200 meters per second. If you want, you can simply say the velocity is equal to 200 meters per second. So that is what we mean when it comes to that. I hope you get the sense of that. Now if you again try to look at the C part there. So if you look at the C part that we have there, so the C part there says figure C3.1 shows a vibrating string at the end. So it is fixed, then it is actually vibrating, forming up what we call nodes and antinodes. Then it says calculate the period of the wave. So they want us to calculate, in this case, the period of the wave. So how do we calculate in this case the period for part C? Well, they have given you calculate the period of the wave with the frequency. So they have given us the frequency, which is equal to 25 Hz, and the velocity in this case is 300 meters per second. Now the question says we calculate the period, so we don't need to fool ourselves. You need to remember that period can also be given by 1 divided by the frequency. In this case, they have given you the frequency, so it will be 1 divided by the frequency, which is 25. If you punch it into your calculator, you are going to find that 1 divided by 25 is simply going to give you 0.04, and this is in seconds. So this is what they wanted you to get there. So you didn't need to struggle, and that was carrying just 2 marks. Well, let's conclude up and try to look at the other questions that they gave us in this exam. So the other questions that they gave us, allow me just to flip this one and look at the other question that they actually gave us. So the D part there was saying state 2 characteristic of sound characteristic of sound waves. So when we talk about characteristic of sound waves, just like any other waves, sound waves also have characteristics or properties, as we can call them. One, the properties of a sound wave is that a sound wave has a wavelength. And obviously when you talk about wavelength, we use the symbol lambda. It is simply the distance between two crests or troughs that are in the same phase. And that is what we simply call as being wavelength. Or if you want, you can simply say it's a distance at which a wave actually repeats itself. Another characteristic or property of a wave is what we call as being amplitude. So sound waves have the amplitude, and if you look at the amplitude, it is simply the maximum displacement of a wave from its rest position. The other one that we can simply talk about is the frequency. Now when we talk about frequency, we simply mean how many, the number of complete waves that are made in 1 second, or per second as we call it. Another one that I can simply give you is what we call as being the velocity, or you can simply say as being the speed. So these are characteristic or properties of the wave. And if you look at things like the wavelength, the frequency, and the speed, they are connected by the wave equation. If you remember, wavelength multiplied by frequency. I know in some books you may actually write it as being you may write it differently. You may say frequency times wavelength is just the same, but that's the equation that connects them, and that is what we call the wave equation. All right, so these are characteristics that you need to remember. Now the other question there says give 2 ways of minimizing sound pollution. Well, there are so many ways. It depends with where the sound is actually being produced. But if, for example, you are dealing maybe with a home, is it music that is playing inside the house, you can simply use maybe sound absorbing. So you can use sound absorbing materials. So you can use sound absorbing materials. It's a way of trying to minimize sound, or to minimize sound pollution. Another thing that one can actually do, definitely if you are playing a radio, you can actually just lower volume levels. That's what you can do. It's a way, lower volume levels. That's another way you can actually get to do that. Sometimes you can simply close windows and doors. It's another way, or using what we call a double glazed windows, those that have got 2 layers in this case, and there's a barrier between. If you're working in industry or machinery, what you can simply do is simply wearing protective. So you can actually wear protective gears, such as earplugs. So most of the people would actually use earplugs to plug them. Sometimes what you can do, the machine can actually be put in what we call as being a sound soundproof absorbent type of material, so it can be surrounded by that, so that the sound can actually be limited to that particular room. So it will depend with where the pollution is coming from and how you can minimize it. So this question may actually be broader when it comes to answering it. Right, then when we talk about F there, it says, what does loudness of sound depend on? So loudness of sound, you need to remember it depends on the amplitude. So it depends on the amplitude, and it follows that the higher the amplitude, it simply means that the louder that the sound is. For example, if I was to draw a wave there, I draw a wave like that, and I try to draw another wave. In this case, I can try to draw it like that, and I tell you if this is A and that is B, which one is a louder sound? Of course, A is a louder sound because it has got a high it has a high amplitude. So loudness of sound depends on what we call the amplitude. Watch out for some more videos.